All right, here we go. Question number 11 from our Precalculus homework number 2 in My Lab Math. We have another interactive figure problem. It says check the x-intercepts and vertex boxes once the window opens. Use the h and k sliders to graph a quadratic function whose vertex is at 3, -8. And then they want us to adjust the a slider until one x-intercept is at 5, 0. They want to know what are the coordinates of the second x-intercept. Okay, here we go. First step, checking the x-intercepts and the y-intercepts boxes. Then setting the vertex to 3, -8. And this is a little picky. It's a little sensitive. All right, so what I wanted to point out, if you're like me and you're having trouble getting that to get exactly on 3, what you can do is if you get close, you can use the arrows on the keyboard and you can just move over like 1/10 at a time until you get exactly 3. And our k was -8. So we're going to move that all the way over to -8. Again, I can't, it's picky, so I'm going to use the arrows on the keyboard to slowly move that over to -8. And that gets our vertex h, k to be 3, -8. So moving the slider, and again, this looks like it's going to be picky, but there it is. Getting an x-intercept to be 5, 0 shows that the other x-intercept would occur at 1, 0. Now, before I input the answer, I do like to use these homework assignments as a teachable moment. So I would like to consider how would we answer this question if we did not have a graphing tool like we used in our interactive figure. Let's walk through the steps to answer this question algebraically. If we know the vertex is given, then we're going to start with vertex form, and we're going to plug in for h and k, 3 and -8. We are going to use the x-intercept given as a generic x and y, and with that information, that will allow me to find a, which would actually give me the quadratic function for this given scenario. All right, so here we go. F of x is y. From our x-intercept, y is 0. A is our unknown. The x-coordinate of the x-intercept is 5. H comes from the vertex, and so does k. And now we can solve for a. Moving the -8 to the other side makes it positive. 5 minus 3 is 2. 2 squared is 4. And then if I divide both sides by 4, I'm going to get an a value of 2. And I would like to flash back here real quick just to verify that that was the a value that we had to set the slider to get our x-intercept of 5, 0. Okay, once we have our a value, we're going to come back to our vertex form of the quadratic function. We're going to replace a, h, and k with what they were given to be. So x minus 3 squared minus 8. And now that we have our quadratic function, we can now find the x-intercepts, knowing that the x-intercepts occur when y is 0. So first step, solving this equation, we're going to bring the 8 over, making it plus 8. Next step would be to divide both sides by 2. That's going to give us 4 equals x minus 3 squared. At this point, we can take the square root of both sides to get rid of the squared. Don't forget that when you take the square root of both sides, you get a plus and a minus answer. Square root of 4 is 2. Now we just have x minus 3. And one more step and we're done. Bringing the -3 over makes it positive 3. And then if we do the plus and the minus, we're going to get our two x-intercepts. So 3 plus 2 is 5. Notice that was the x-intercept given. 3 minus 2 is 1. That is the x-intercept we found from the interactive figure. So this is the algebraic approach to solving this particular problem. And notice it does say type an ordered pair, so please don't miss this just because you didn't input your x-intercept as an ordered pair. Whew, and we're done. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me, and thanks for watching.